Mikrofon 1, mikrofon 1. Mikrofon 1. Mikrofon 1. Mikrofon 1, mikrofon 1. 1. Mikrofon 1. Mikrofon 1. 1. Mikrofon 1, mikrofon 1. 1. Mikrofon 1. Mikrofon 1. 1. Mikrofon 1, mikrofon 1. 1. Mikrofon 1.
Test mikrofonu. Já myslím, že může. 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 Okay, we have
Can we keep in the sticker instead of copy?
what's hidden?
Can you keep in the flash drive instead of copy?
Use the flash drive one. Okay.
Did you copy?
It's copied. Like
Okay.
it's copied.
We use what is there.
Yeah.
Later on, I just need you to delete.
Yeah, sure.
Because there are some components on it.
Chris?
Go ahead.
Good morning. Good morning, everybody. Nice to see so many faces, curious faces interested in the case study that EATON defined. I hope you will enjoy the topic, and we are really looking forward to see some very interesting proposals that will come as a result of your tries to chase the study, the topic that we have. But for the beginning, before I start introducing the topic and EATON as such, we would like to run a short movie that would get you an insight what EATON does and what EATON is about. Sorry? Yeah. Okay. Okay, so first slide, please. So, planes, hospitals, data centers, airplanes, vehicles, the electrical grid. These are things people depend on. And companies behind them depend on EATON to help out to solve some of the toughest power management challenges in the planet. For centuries, finding, generating, and harvesting energy has been one of the mankind's greatest challenges. But today we are facing even greater challenges. I would like to call out just a couple of examples to give you an understanding what does that mean. These new challenges will actually are already influencing the way we live and will live in the future for next decade. As one example, for example, by 2050, it is expected that energy demand will increase by 60% just to heat up and cool our houses. Or in the next 3 decades, the population on Earth will reach 9.5 billion people, and these people need to be fed. So the food production is expected to grow by 70% overall. And all these new people will live mainly in urban areas, and actually this will impact many other things, such as, for example, that agriculture yields will need to be increased. We will do many investment into infrastructure of communities or into utilities. So these are the global challenges that we are facing on. Next slide, please. We at EATON believe that we owe it to future generations to leave the world a bit greener than it is today. The power to make this is in our hands. We all make it happen. As one of the world's leading global technology company, we are committed to really have positive impact on the environment while delivering solutions that will help out to resolve some of these biggest power management challenges. We do that by providing tools to our customers that help them to manage the energy in more efficient way, and by helping companies to run their business much more efficiently. And this is really what matters. Next slide, please. Yeah, here's a brief snapshot at EATON. EATON is a global power management company helping our customers to use the energy in more reliable, efficient, and sustainable way, serving the needs of customers across the whole world. We have approximately 175 countries. Our products combine electrical products, hydraulic products, mechanical products, and yeah. So okay, yes. So now I would like to hand you over to Jessie.
Good morning, everyone. Can you hear me okay? Were you hearing Andre okay? So before we talk about products, technology, let's talk about people, right? Because without people, we don't do new products. Without people that has different ideas, we cannot create any new innovation, yeah? So let me start talking about people, about the team that is here with you, yeah? So Andrea, who was talking with you, is a manager in our innovation center in Prague, and she has been 5 years with us now, yeah? So definitely a lot of new, hopefully new patents coming from her and from her group. Amjad is also part of that group, and he was, in Finland, now is in Czech Republic, yeah? So Andrea is Czech. Amit is coming from Pakistan, worked in Finland, and now is here, yeah? We have Dmitry that comes from Russia, and now is one of our engineers also in the Innovation Center. We have Michał, also Czech, and working here in the Innovation Center. And we have Joy coming from the hydraulics business in UK. Now, I come from Brazil, and yeah, it's a little bit different. So it's a mix of people that we work together, and we are able to have different views, different perspectives, and get collaboration in this company. So if we have 95,000 or 97,000 employees across the globe in different countries, the best way for us to create new products is to get these people together. Yeah? And that's why we are here today as well, to get to know your perspective, because we have people from different countries here, correct? Yeah? That is the second year that EATON sponsors this event. And hopefully I think we're going to sponsor more and more, yeah? Because it's so kind of refreshing to get directly with the university team and give you some ideas what we are doing, so you can get to know our company and how we work with the training and opportunities for people. So we have an inclusion and diversity pillar in our company, and this pillar has 4 points. The talent. So we look for attracting talents in different universities, and that's why we are here today. We get to know you. Yeah, you get to know us. We look for performance. As we get these different people from different countries together, there are different skills. Yeah, you always have to have a French person to talk about different problems. You have to have the German to get things, in the experience. You have to have, the other people for marketing and so forth. Just 2 examples, okay? There's so many. Globalization. Our products are global. We produce products, for example, in the manufacturing plant I come from in Germany, that is sold everywhere. Yeah, so we have to have different legislations around it. And innovation. When you get all these people together, definitely there will be very, very good ideas. As today you have your teams in 4 or 5 people, definitely we are looking for good ideas. So we have this very clear for us. And just as an example, how many events we supported already this year, okay? So we supported a Society of Women Engineers. There was a nice congress in Amsterdam, or 3 days congress in Amsterdam. We supported that, and we also brought our female engineers to that event. We support the Hanover Fair. There was a congress there for a full day. 15,000 people were there, and we supported as well. As I said, this is the 2nd year we are here supporting BES. Last year we have a very nice event about augmented reality. We had workshops in the universities in Romania, Cluj and Baia universities. I think we might have some people from Romania here as well. Okay, good. And we have internally several career tools, and we have internally several different trainings for our engineers and all the workforce. So we look forward to work with you and you to get to know us. Just one question, how many people knew EATON before this event? Well, that's better, huh? Last year was 0. That's good. So enjoy your day with our problem. And in the next slide, I also want to share with you, we have inside the company some we call resource groups, and they help on different topics, discussion. There is one resource group for the young generation, it's called Engage, and that's another reason why we're here with you today. And in every one of these discussion groups, we look for a new problem. So we bring you a new problem now. Okay? Thank you.
Okay, so let me give you a detailed introduction into the case study, into the topic. Okay, so these are the most significant trends, or if you want, mega trends that shape the way we think about our solution. On top of that picture, you can see industry convergence. In the last years, the commercial and industrial applications have been converging each to other. We are starting to see use of technologies which actually originally started as purely commercial technologies, starting to penetrate into industrial applications. As an example, for example, use of mobile phones and apps in connection with machines, or 3D printing, which was actually created by hobbyist enthusiasts that wanted to create 3D printers, and now the 3D printers have evolved into and got the maturity that allows their industrial use with it. So as another example, power electronics, we are seeing that power electronic solid state technology is starting to replace traditional electromechanical switching, use of wide bandgap devices, use of advanced materials like polymers and nanomaterials. I already talked about 3D printing. Open innovation, the white lens approach where we are striving for really broad collaboration with universities, because universities can very nicely complement the expertise that we don't have in our R&D departments. And on the other side, we can provide them with really tangible industrial business cases that needs to be resolved. Flexible energy management. We will need to provide flexible energy management solutions that would fit the needs for both, for developed but also for emerging nations. Yeah, next slide, please. So, yeah, here we have the 4 basic elements that every IoT-enabled application should have, meaning industrial IoT-enabled application. So, basically, all the assets on the field level will need to be digitized. That means that every single sensor or actuator will need to provide the digital information over some communication line to the application. Yeah, so these things are becoming intelligent. They can also often make their own decisions based on the information that they can gather from their neighbors, and can provide, for example, functions like smart analytics for predictive maintenance. For example, a motor can report on a need that some part of a motor needs to be replaced due to wear out, as an example. Connectivity. Use of IP-based protocols for getting these things connected to cloud, for example. We need to aggregate and disseminate a really large amount of data, and this brings me to data science, where we really need to translate this raw data into valuable information. Because having a lot amount of raw data does not bring any help to the customer who would like to analyze out of this some information that would help to maybe optimize a business. And last but not least, we need to innovation is when you are able to monetize your valuable novelties. We should not develop technologies for the technology's sake itself. Yeah? We need to provide ways how to develop a reasonable, scalable, and profitable business case by using all these technologies. This is all this business model is about. Okay, next slide, please. Yeah, now I would like to hand you over to Amjad, who will give you.
Thank you. Is it working? Okay, thank you. As was introduced, my name is Amjad Hussain. So I'm working in Corporate Research and Technology Division of EATON Corporation. So we are a global team based in different locations around the globe. So we have our team members sitting in Pune, India, and in Shanghai, in United States, in Milwaukee and Pittsburgh. So what we are doing, we are actually looking forward to the future technologies. That's our job. And we try to bring new solutions for the current challenges, and solutions might not be the immediate ones, but they may come in the market after 5 years or 7 years, and so. So now we are looking forward to the future of electrification and electrical power distribution. How many of you guys know what was the biggest invention of the last century? Anybody?
The light bulb.
Pretty close, but it was electrification, which means like electrical infrastructure. Main of these components are like power distribution. So how you generate power and distribute to the end users. So that was the biggest invention. All other things, semiconductors, IT, telecommunication, they comes down. We have, which tells that we have done a lot. We have achieved a lot in electrification and electrical power distribution and power systems, but we still have to do more. Why? Because now world is changing, and there are lots of more challenges, such as we have biggest problem of global warming. So we should think about alternative energy resources, renewable energy resources, and then we have now more natural disasters, especially in United States or in somewhere in Asian countries. So as you know, tsunamis, and so yeah. And then we have also a problem with aging of our infrastructure. Conventionally, we have long transmission lines which are aging, and due to these disasters, they may get damaged, and a big area can be out of power. So we are now moving towards renewables and distributed generation. And we have been talking a lot about smart energy systems, smart grids. How can we make it smart? As Andrea said, now we have available state-of-the-art telecommunication technologies, connectivity, wireless connectivity, and artificial intelligence, and sensing technologies, and we can use all of them and create a business model which can benefit end users in a better way and in a sustainable way in the long run. And this is how we come up with some of our products are already employed in our power systems. These are smart, they have sensors, they have intelligence, they have digital signal processing and fast fault detection. And so, yeah, you can see there are some smart controllers and smart inverters and smart circuit breakers, smart power distribution boards. Why we call it smart? Because they are able to detect at quite fast sampling rate and communicate at very high speed, and then we can manage the system, or we can protect or restrain our system in a better way. Next, please. Yeah, so these are some of the products which EATON has already, which are like enabler for smart grid and smart power distribution. Starting from here, eventually we used to have dump reclosers, circuit breakers, or relays, so which used to have like only a standalone or local capabilities. But now we have advanced capabilities. We can really control them remotely from our control room, or we can have an integrated smart control by using communication between different coordinating devices. So we have smarter breakers and smarter relays, and also switch gears and switchboards, and these are also getting smarter. Same with the smart inverters and other components. You can see some of them here. So next, please. Yeah, so this is our recent development in our corporate research and technology. So we have developed a smart controller for our microgrids. The definition of microgrid is a grid which can operate while connected to the main grid, or while disconnected from the main grid, and it can operate autonomously as an islanded or isolated system. So this device can communicate with different devices, such as your circuit breakers and your chargers for batteries, and inverters for your energy storage, and also for photovoltaic, and different controllable loads which you can think of nowadays. So we are not really at that point where we can really employ it widely, because we already had existing legacy system, and it will be a little bit slower change until we get all the devices, all the components in our power system, such as our distribution panels, our recloser, circuit breakers. All of them will be smart, which means they will be able to communicate, and they will be able to detect any kind of incidents in very short time. Short time means we are talking about nanoseconds and microseconds, not even milliseconds. Yeah. So yeah. So the basic objectives or concepts why we developed, and what were the needs, were like to have something which can be suitable to get optimization strategies, so that in an islanded system we get minimal operational cost. And this device is pre-engineered, 75% pre-engineered, so most of the algorithms, most of the controls are there, but it can be, of course, customized according to the system, according to the customer needs, and so on. And it's plug and play, it's modular and scalable, so it can easily be adapted to the to different size of your microgrid. Yeah. So. Yeah, and customers, EATON differentiator is like we have our mature power system engineering team worldwide, so we can provide continuous support to the utility companies, to the end users, and yeah, and we have already been doing a lot of business in this area in electrical sector, and people do really believe in us, and this is an advantage for us. So this is how we're gonna take it from here. Next, please. Yeah, next. So here are some of the objectives, some of the functions which we actually thought of when we were developing this Power Expert Energy Optimizer or Smart Controller for microgrid. You can also probably note down only the headings which may be useful in your tasks when you will be working on these tasks. So system design, which means we should design a kind of system which is modular and which is based on standard communication protocol, which means you can just plug and play, and you can plug into any kind of system, and you don't need to make bigger changes in the existing infrastructure. And yeah, so because we already have a legacy AC system, and they already have some existing protocols, so we should think of that, and our device should be compatible to communicate with the existing devices. And it should be adaptable for the future changes. Next, please. Yeah, next one is seamless islanding, which means like whenever the fault occurs or whenever some incident occurs, whenever there is some big change, so you can isolate the system, but the end users or the customers, they won't really differentiate, or they won't really realize it that there was any change or any infrastructure modification. So it should have fast fault detection, isolation, and safety interlocks, and yeah, and it should have efficient source management, load shedding, and grid reconnection. Next, please. Yeah, so next one is black start. Black start means like when you want to start a system, you don't really start everything at once. So you start with minimum of resources, such as minimal generation assets, and then you sequentially start putting on loads. So, and yeah, you should think about that. Next, please. Yeah, and next, frequency and voltage control, quite well-known existing concept. So we have been struggling a lot conventionally with our voltage and frequency control. There have been a lot of incidents in India, Pakistan, in Brazil, that whenever fault occurred and there was a mismatch between frequency and voltage, and due to mismatch in demand and supply of power, and so protection devices couldn't really control this kind of fast changes in assets. So there was result was a big area was out of power. So you should think about that. Next, please. Yeah, and system balance, of course, you should always try to meet the demands in an optimized way, so that your operational cost, it is restricted by a certain level. So you should always try to balance demand and supply. So conventionally, it was being used by putting more and more generations, but now we have demand response and demand side management, so we can actually shift the loads, some of our loads, and some of the interruptible loads, not the critical ones. So we can turn them off, and we can use them some other time. And integration of renewables and optimization. Of course, we should have more smart devices, such as smart inverters, which can synchronize your generation with the grid voltage and power. Next. Yeah, and last but not the least, our main objective must be lowest cost. So this is what you have to think about. And yeah, and demand response, as I said, it is a good way to control your energy bills by shifting some of your loads from peak hours to another hour. So it is also called peak shaving or load shifting. and this concept is getting quite popular here now in Europe. Next. Okay, so some of you might not know what is the difference between AC and DC. I believe most of you are from electrical engineering background, but still just wanted to give you a quick review. Yes. Next. So AC is alternating current. It stands for alternating current, and it's analogous to pumping water through a closed tunnel or path. So there is no in and out. There is no net water flow, but all the water is inside the pipe, and you are just pumping in, out, and back and forth. So this is how AC works, and yeah. And why we used AC? There have been in 1880s. There have been a war between Edison and Tesla. Probably you might know already. So there was this fight that whether AC is more sustainable or more operable or DC. So why we picked AC that time? Because it was pretty easy to step up the voltage level using transformers, which work on the Faraday's law of electromagnetic induction, and they don't work for DC. So yeah, that's why we used AC, and why we needed to step up, because that time we had remote generation and long distance power transmission. So there was one power plant which was like 300 kilometers from certain locations. So the power was transmitted from that power plant. But now we have distributed generation, so we are thinking differently now. Yeah. So next. And now we have DC, which means like direct current is a continuous flow from one direction. Thinking about battery, why your battery depletes, why your battery drains away, because there is a continuous draw out of charges from the battery, and there is this constant level of voltage or current. And simple example of DC network is you have PV panels which produce DC, and then you can supply power to the DC loads. We are everybody in this world now thinking about renewables. So most of the renewables like photovoltaic, fuel cells, and also wind turbines, they produce DC. So wind turbines, they produce AC, but it's more like fluctuating, and you need to anyway synchronize it with the grid. So you need a DC connection, like so AC to first you convert it to from AC to DC, and then from DC to AC. So there is a DC link between there anyway. Yeah. So next, please. Yeah. Why DC distribution? Your task is also related to that. Why DC distribution? Because simply it's efficient to integrate different DERs, distributed energy resources, as I said, which produce mostly DC. So it's pretty easy to integrate compared to AC. In AC, you have synchronization problem. You should think about phase shifting. Your phases should be synchronized. Your and your this power factor and your you have an issue with the reactive power. But in DC, you don't have those kind of problems. And yeah, and it's more economical, lower operational cost in photovoltaic, wind turbines, in hydel. Yeah, most of them are like there is no fuel required for that. And it's more energy efficient, of course, because there are less conversions involved. Unlike the AC system, you have lots of AC transformers, and efficiency is pretty low. And then anyway, you have different kinds of loads nowadays which work on DC. For example, your laptop, mobile phones, your television, your all the power electronic devices or electronic appliances, they work on DC. So even your air conditioning, they use variable speed drive, and they are more efficient on DC. And it should be interactive and resilient, which means it can interact between different systems, DC systems or AC systems, and also it's resilient, which means like it can reinstate during any fault condition or any yeah. So difference between a simple DC home and DC microgrid, what I have been talking about is that DC home is simple. It connects different renewables, DERs, and then you just need a simple controller to stabilize the voltage levels and to connect different loads. There are no major challenge in that, but the biggest problem will be when you connect lots of DC homes, then you will have a bigger problem. You will have problem of power quality, reliability, and you can think of that. So in DC microgrid, you have it's like if you connect multiple DC homes, or if you think about a business park where you have small industry, where you have offices and lots of different types of loads and different types of generations are there. So you may have system stability problem, coordination issue, control and optimization, and safety and protection of your electrical lines. So you need to find solution for that. Yeah, and these are some examples and comparison between DC and AC systems. So conventionally we had AC, and your lots of devices were really passive, like your transformers and your protection schemes and everything. And yeah, why? Because we used to have generation at remote site, and we were transferring power from relatively larger distance, and our loads were also passive. And yeah, and there have been existing lots of standards and rules, regulations which needed to be followed to have a stable system. And now, during last 2 decades, we have been talking about smart grid, smart systems, and until now, there haven't been any definite answer to how we can establish a smart AC grid. So now we are rethinking, and we are talking about smart DC grid, so which is DC microgrid. So we have all the efficient power generation assets like renewables and distributed generation, and we have lots of DC loads. So and it can interact with the AC system as well. So we can still have this hybrid system, and whenever our renewables are not producing sufficient power, we can draw power from AC system. Next. Yeah, and these are some of the popular use cases which are widespread now almost everywhere. So even in small homes. So people are using, first scenario is that parking lots with electric vehicle charging stations. So it's more efficient to have DC there. And then in smart homes where you have photovoltaic and EV charging station, and in data center is a biggest supporter of DC distribution, because obviously it's all the load is DC, so all your servers and your hard drive or storage units and these things, they all work on DC. So requirements for DC power distribution, of course, you should have distributed on-site generation. Then it makes sense, and you should have energy storage, so that when you don't need electricity, you still have this solar power, for example, or wind power. So you can store the energy and use it during other times, for example, at night. And yeah, there have been widespread adoption worldwide, especially in the areas where there haven't been electricity so far, for example, in Africa and India. So now new installations are mainly on DC. Next, please. Yeah, so another quick review of why we are again thinking about DC. So we have our motors, as I said, they work on our HVAC system, they work on variable speed drive or variable frequency drive. They are more efficient with DC, and they consume almost 31% of your home energy or the commercial building. And then we have our our inherently DC loads such as LED lighting and computers and all the electronic devices. So they take almost 32% of the power, and then rest of the 37% is some of the equipment. They can work both on AC and DC. For example, your space heaters, they are simply resistors, so they can work either on AC or DC. So it doesn't matter for them. And some of the equipment, of course, can still be on AC, but you can easily have DC to AC converters just next to that device, or yeah. One popular application or one popular use case is to adopt DC distribution starting from your home. In India, they launched this nationwide project supported by Ministry of Energy in India, and it's they have already installed this kind of DC system in small homes, like photovoltaic panel, one photovoltaic panel, and then batteries and some small controllers and some DC loads, and they have installed to 40,000 homes. Can you imagine? So in India, roughly 15 to 20% of the area is still deprived from electricity at the moment. They don't have electricity. So now they are having this kind of DC power there. And in existing infrastructure, such as in Europe, we can start with having a small DC system in our home, starting from your garage, because your electric vehicles, they are charged by DC. So, yeah. And then you can extend it to further, you can enable it to power your other appliances as well, and you can have your residential energy storage as well. We have, EATON has this X storage product, you can Google it. So it's really a smart device. You can store energy, and you can connect your AC system with that, your PV panels, and your some of the equipment. Yeah. So that's all, I think. Next, please. Yeah. So.
Please stay here for additional questions. So thank you, Amjad, for a very detailed insight into this topic. For the to close just briefly, these are the evaluation criteria according to which we will evaluate your presentations. Yeah. So first criterion will be a topic research depth. Second criterion will be technical maturity of the proposal. Third one, feasibility of the proposal. And last but not least, presentation performance. Presentation performance will be evaluated in two, let's say, dimensions, meaning so using of soft skills and language use. And the second dimension will be the ability to answer jurist questions. Yeah. And every criterion, as we call out them here, will be scored by marks 0 to 5. And then we will calculate the final scoring by using these 4 numbers. Next slide, please. Yeah, this is the jury committee. As Jessil introduced in the beginning, the jury committee is consisting from people. It's consisted by people from EATON. The expertise ranges from manufacturing till engineering to engineering. Yeah, next slide, please. And yeah, to motivate you also for really presenting the best performance you can. The first 3 teams will be awarded. Yeah, so first place will get a quadrocopter, or first team will get a quadrocopter. Second will get a Kindle reader, and third one will get a wireless Bluetooth speaker. So hopefully it will motivate you a bit. Okay. Yeah.
What we are asking you to do is to create
The task is described in details in the case study documentation. So I don't have it here covered in this presentation. Michal, would you please? Okay.
You can always come and discuss with me in person, but yeah.
Sometimes one question is the question for
Yeah,
many.
yeah, sure.
So we're actually talking about the one place only AC things, right?
Sorry?
There exist two ways, two types of alternative currents. There's one phase and three phase.
Mm-hmm.
So we're talking only about one phase. Because the three phase is the better way to explore.
It's three phase. There are three wires.
On this picture. No, this was just general introduction
this is just
into
like
AC and DC.
Because on the graphic there is only one phase.
Feel free to any system you believe would be the best fit for the solution.
Yeah.
Just one more question. It's about distances. So what distances are we dealing with? It's like kilometers or meters?
No, we are not talking here about design of distribution networks. We are really looking into home, into smart grid for homes. Yeah. So yeah.
In smart.
Yeah.
That's what I was talking again and again, because now we are moving to the distributed generation, to the local generation in a small town, in a village or in a business park. So that's
This,
how we
this slide, the purpose of this slide was really to give you only an understanding in where AC is maybe more or better to use, and where DC would advance. Yeah. I think it should be possible. Yeah. We need to discuss with organizers where to upload it, and yeah.
Okay, so guys, one more minute. I will tell you some technical things about this case study. You already have the handout distributed in your room, so you can go there directly and take the handout, read
8 minutes, yeah, yeah, yeah. And 5 minutes for our questions. No, no, just the presentation will be fine. Yeah.
Okay, teamwork first, I guess. One of you guys. Yeah. What? Once again?
We will try to provide a clicker for this presentation to make things more slowly.
Okay, there, I don't know who was first.
Are those extensions necessary to do, or
What? Sorry?
those extension tasks are necessary to do, or
Yes, actually, those will be evaluated. Those extensions will be evaluated in the same way as the key topic.
so basically we've got to do
2 marks. You will get 2. You will get 2 marks. Yeah.
all right.
Should-
Okay, what time is now? 8 o'clock? So we missed some time here with the presentation, okay? So we will give you this time back. Okay? We'll give you this time back.
Okay. And no, wait, the last thing, we will send you an email.
That should not be published. That we have
This
the extension.
with the PDF version of the handout.
We wanted to have it as a surprise for the teams
And all the links.
to cause a little bit panic.
Yeah.
Check